Right, so one day, stay a little longer, or give some more. Right? When it comes to a little longer. Right. So standard deviation, right? What is standard deviation? Let's pretend we knew a mean. And let's say the mean value was 4. Right? Suppose I gave you some values and the mean value is 4. Right? And I gave you some value that looks like this: 2, 2, 3, 4, 5, 7, 8, 9. Right? Let's pretend that the mean is 4. What the standard deviation tells us? It tells us how far this set of data is here from the mean. Okay? So your standard deviation type, if you an idea, look at it. Yeah. Right? So if you look there, that mean value of 4, right? What is standard deviation? A standard deviation here might be about, and that's making up something, right? Maybe like 2.3 or something, right? It gives you an idea of how far away from the mean you actually are. The bigger the standard deviation, it means that your values are actually far from the mean. So for example, if I put a value like 20, that 20 will show you standard deviation over, because your values now are very, very far away from the mean. Okay? If your values go like this, 3.1, 3.7, 4.1, 4.5, and so on, that will give you a very small standard deviation. Right? Why? Because the values close to the mean. That's okay? Right? So, big standard deviation, far from the mean. Small standard deviation, close to the mean. That's all. All right? So, I'm going to give you a few values, and we're going to find, using that formula, we're going to find the standard deviation. Right? Write this formula, please. Standard deviation, I write it over. It's the square root of, you're summing all the x values minus the mean, and then it's squaring it all over the total number of values. Right? I'm going to forget this one, right? I am going to show you how to work this out. Summation. Stop. Remember we did something called summation. All right. I was never done. You think it actually was never done. Right. Copy it down. I'm going to explain how to use this formula. What? I'm going to show you. Yeah. I'm going to show you. Right? The standard deviation symbol is a funny looking 6, right? All right, so let's go to this commodity board, right? Let's go to the board. I want to show you what to do, right? Ready? Yeah, what do you want? You didn't want to start it. Ready? All right. Before we start to use the formula, right? I want you to find the mean here for now. Find the mean. The mean is adding up all the x values and then dividing it by the total number of values. Oh, yeah. I want to give you 6 values, right? Look out the mean that. I don't do good. Okay. Find the by the x and the mean in the bracket. Because again, I got something that's square. I'm going to show you how to use it. I'm going to show you how to use this just now. Yeah, add it up and then divide by n. Take your time, write down the values, and let's find the mean, right? Find the standard deviation. Find the standard deviation. Online, are you okay there? Are you weekends? How much you all got for the mean? 10.5. Everybody got that? Yes, it is 10.5. Right. Here's what we're doing now. We're going to use a table to help us find standard deviation. Okay? And I'll talk to you about variance one time. Actually, I should do that one time. Standard deviation. Right? And there's something called variance, which is not really a quantity that we always need because this is what we need. But variance is basically a standard deviation squared. That's all. Right? Just square this value and you'll get a variance. All right, nice. So we're gonna do a little table method here to help us find a standard deviation. Right? So we know the mean 10.5, 10.5, 10.5, 10.5, 10.5. You're gonna minus each value and you'll get it here. And then take this value now and square. Okay? Right? So it will be 5 minus 10.5, which is minus 4.5. No, wrong, 5.5. Minus 5.5. Next one, minus 3.5. Next one, minus 1.5. Here, 0.5. Here, 4.5. Here, 6.5. Right? And then square it up from up. Square them. Don't round off too much. Then we can put it see that small places, right? I'll send that one. How much is this? How much is it? You already share? Yeah. Just square them all out already. How much you get here? Remember you're squaring this, right? 30 points. Next one. Next one. Up. Next one. Next one. 20. Last one. 42.2. Nice. Right? So, and them up now. Right? So, actually, you're asking what is summation symbol mean? It means sum it all up. Okay? Right? So what we find in here is the summation of x minus x bar squared. That's what we find in here. Okay? Copy it down. At the top, come over again. One oh 7.5. Yeah. 107.5. Right? Now wrap it up. Summation, sorry. The sigma is the square root of this value, 107.5, divided by n. We have 1, 2, 3, 4, 5, 6 values. That's it. I think just give it this formula. I think. In front of the past paper. Online, you're okay there? You got this value. Check and make sure you got this value. Yeah, look, just give it to you, but it don't look so. It look a little tricky, but it's give it to you, right? Just give it the same formula. Just give S squared. I've heard like how to put but they give it using S squared. So they give it the square root of it. Right, so that's why this square, they give it a variance. Right, so you already have to live. Guys, if it's this is if it's I'll show you that one. What they give you anything? How much you all got for standard deviation? 4.23. Right? So that gives you an idea of how far away the values are from the mean. Right? So the mean is 10.5 and the values are about on average 4.23 away. That's okay? What would happen if I put a value like 11 there? Would that make it standard deviation bigger or smaller? Smaller, a little smaller, right? If I put a value there like 1. Right? Which should be a little larger, right? That's what's it? What's the favorite? All right. So again, everything here has to do with on group data, right? We're gonna try it now with group data. Right? I wanted to show you something here. If you look at the front of your past paper, there's given the formula, right? Let me show you how it is, right? But instead of the square root, they are giving it S squared. Watch down here. Right? That's the formula for mean. It's looking a little weird, but that's the formula for mean. Sum of X on n. Right? All they did is just put T and I goes from 1 to n, right? But you don't have to put that T. Right? Watch here. That's the formula for standard deviation. But they give you variance. Right? So it's the same thing. Just square root that. Okay? So you don't really have to learn this, it's in your formula sheet, but you might have to learn it for and the two. I'm gonna just take it with it some any problems. Alright? Alright, nice. Now we're moving on to handling group data. Group data, the problem with group data is that the value is grouped up and they're given a frequency. Okay, so we have to figure out how we get F and how we get X. Right? F easy. F will come in the frequency column. But X, remember, you're going to have intervals. Anybody knows how to get X? Up. The mean. Middle average, right? With here, midpoint. So add them up and divide by 2. Right? Add them up and divide by 2. That's okay? Add them up and divide by 2. All right. Should I get you more familiar with this one, right? Yeah. I'm gonna get you familiar with this one. Do me a favor, head up group data and write down this formula here and write down this formula here. Remember that formula is S squared, right? I'm going to show you how to use it now. Head up group data and write down that version instead, because then that's the version that you'll see in the exam, right? If I can come up here a little bit. Yeah. Yeah.
Right, S straight up negative X.
You're right. What? You're right. Again, you don't have box around, right? To the one better box it up. This is the formula for me. I have like that. Yes, ma'am.
So my is one it's supposed to pass.
Well, ma'am, that's what I'm showing you here, ma'am. I standard deviation. Yeah, X bar. Right? So the first one is X bar, and the second one is S squared. This is X bar, this is S squared. If you don't want to write the squared, square root the whole thing. Okay, but the same thing, right? Copy it down, write the formula. Standard deviation S here. S squared variance. So what's the head up group data. Right? Dealing with grouped data now. And write those two formulas. Yeah, write it like that. Now, so again, you said, once you understand it, you don't have to. Yes. All that's saying is I going from 1 to n. That's I equal to 1. Write everything so you know what it means. I'm going to show you what it means now, right? No, that's I. All that means is add up what? All it means is that I is 1 is your first value. That's all. Yeah, now your first, second, third, fourth, fifth, sixth value. And in 6, I is 1. Ready?
S.
Yeah, S squared is area, sigma squared. Am I writing online still? So we have one x1. I'm going to show you what it means just now. All you really interested in is summing up f by x squared and you divide it by the sum of them. And then you minus the mean squared. That's all. Watch about when you watch a video, right? That will why I score. I think I like it. They will give you some score. Right? Well, that's why I will they will magically come up with things up and I don't have things. But this way come up. You can get TikTok like what I mean, you all right, let's start. Let's take a look at this example here. Let's take a look at this here. Hold on. Right here we had an example of one group data. Quartiles. Wait, where's my group data? Nice. Let's go here. So here's the formula for standard deviation and mean without all those fancy notations. That's the formula there, right? Please remember that. Oh no, what just happened? Right. Please remember that in this formula for group data, this symbol here is mean, right? That symbol there is mean. Okay, so what do we need? We need f, we need x, we need to square them and multiply them, and then sum them up. Right? So I'm going to show you a nice table how to work out standard deviation for group data. Okay, so watch this here. Watch this example here. Nice. We're going to go through each column one by one, right? Right. So here we have a nice table, only 4 intervals, 1, 2, 3, 4, and their frequencies. Right? You'll clearly see where F come from, right? Yeah? F is this column here. Yeah? But the problem is X. In order to find X, what we have to do is to take the lower class limit, upper class limit, 26.5, plus 31.5 and divided by 2. Okay? Add it up, divide by 2, and what you get. But you know what, the only thing that they use to define take up the algorithm as in a way, start of it. At the start of it, yeah, there's good standard deviation and mean and thing. Like that. Yes, everything Netflix, all those things, all the watching. All those things that we recommend things there. There's by standard deviation. Come, add that to me now, and we'll get at the more you get. 29, right? Add it and divide by 2 and you get 29. Right? So how we getting f by x? Watch me, man. How we getting f by x? You take your frequency value, which is 4, and you multiply by 29, and you get that. Right? Why is f by x? Yeah. Well, we're not done. Right? Why did I do that for you? Oh, yeah. I did that for me. Your mean is sum of f of x on sum of x. Right? That's what I did. Right? Now, square this x value and multiply by 4 and you'll get this. Check it and make sure. Square the f value. Sorry, square the x value, 29. Multiply by 4 and you should get 3364. Okay? And when you add it up, you will get the sum of f of x squared. Right? So 43,950 is the sum of f of x squared. And it does. It does. Right? Once you do this, go to the table now, Elena. Right? Go to your table now and go to your formulas now and find the mean sum of f of x over the sum of f. F of x, f. Okay? And then come to standard deviation. Plug in sum of f of x squared here, plug in your mean, and plug in your f. And you are done. Okay? So that's the way you work this out, right? Any questions online? The best thing to do is use the table. Right, your mom? I'm going to go and go earlier. I think I don't want to go and go. You physics. I pass on. Select one does. Any questions online, Mikai? Are you okay with this? I'm gonna give you an example, right? Mikai? Narayan, you there? Daria, are you okay? Probably. Not today. All right. Let's do an example now. Do I have one here? I don't have one here. I don't. 1 second. I forget one for you. Probability is fun. Probability is fun. Those questions when the value. We don't like probability. Where is it? Where is it? Let's try this one here. Oh wait, you're not seeing it. Look at here. 2015. Find the mean and standard deviation. Please, this is not x, huh? You have to find x, right? Find the mean and standard deviation for this example here. It was at the intervals here. 2015, number 7. Go ahead. Only 4 values. Hurry up. Everybody, put on the phone. Come on. You have no calculator. Take your time, find Find mean and standard deviation. Five to nine is 8, 10 to it was probably from the screen data. That's why you have 0.5 on it. Right? So do find them boundaries. Use those same limits, right? It doesn't affect the X value anyway. Oh yeah, work out that. Add online when you finish message your answer. It's only 4 values, eh? So hurry up. Shouldn't take you long. Huh? Yeah, do the table. Put in that table one time. Take the interval, then write F, then write X, then write Fx, then write Fx squared. Right? Put your intervals, put your frequency. got you? Yeah. Bubble? I get some wood. Tell them. I get Alright, on that, taking this off, right? You need mean and C. You need mean and thing, right? Right. How do you get X? X is what? No, X is not 12. Don't want to say the mean. All right, the middle, midpoint, right? Right? So 5 plus 9 divided by 2. Right? That's 14 divided by 2 is 7. Right? 10 plus 14, that's 24 divided by 2 is 15 plus 19, that's 34. So you'll get, and then 20 minus 24 is, sorry, I said minus, I mean add. Right? What's that? 44? 44, so that's 22. Right, Nathan? And add and fill it out. Okay? I forget you all out. What time will last time? All right. I finish it online, send it to you. Find everything past standard deviation, nothing else. Well, guys. All right, so that's finished up. Wrong. All right. F of X, help them out here. right? That's what, 56, that's 48, this is 170 and 66. F of x squared, help me out there. 3, 1. Remember you square and then multiply by this, right? Yeah? Square this and multiply by this. Square this, multiply by this. Yeah? Next one is what? Huh? Oh, you didn't get this? 3, 9, 2. That's all? So you're squaring 7 and multiply by 8. So that's 49 by 8, right? Okay. Next one. You're not squaring this, you're squaring x, huh? You're squaring x and multiplying by 8. Okay? X squared by 8. 12 squared by 4. Next one is what? 576. Next one is 2,890. Last one is 1,052. Nice. Good. Do me a favor. Sum up here. That'll give us the sum of f of x. How much is that? 3. Then sum up here. That'll give us the sum of f of x squared. Much 5,310. The manner you move for this. And that's it, right? Now we can find the mean. The mean is what? The mean is the sum of f of x, that's this value, divided by the sum of f. Oh, what's sum of f again? 25. Nice. So it will be 340 on 25. How much is that? 13.6. Yeah? Yeah. Israel, are you okay there? Next, we need to get standard deviation. I am using the square root version. Sum of f of x squared over the sum of f minus x bar squared. Okay, so all we have to do is take this value, which is here, 5310 divided by 30, and minus the mean squared. Right, all in the square root. Oh, 25. So all in the square root. Sharp people, if you have a sharp, you're going to have to work out this, then minus this, then square root it, right? Piece by piece. Because you're equating exactly like that. Right? Ready? Come away again, please. 5.24. Right? Like check out online. Anybody get that? Sorry. 5.24. Very good, Amrit. Very good, Sebastian. Somebody up there too. Radisha. Very good. Everybody get those values? Online, you're looking at what went on, Mekai. Are you okay? Yeah. Nathan, you okay with this now? Right, last thing, another non-rush problem today, right? Last thing we have to do is something called skewness. Okay? Skewness gives an idea of how the data is shaped. All right? You're okay? Last thing. That's skewness. I'm not too sure everything is doing. Hold on. I'll tell you if they had it, right? I'm not sure if I have added to this one. This summary is in the LMS for sure. I'm not sure about the name. Yeah, this one in the group chat. Summary for sure there. Right, do I have any skewness here? No, I don't. Yeah, you know what? I don't think putting from here. All right, let's take a look at this here, right? Kind of skewness. I don't have those diagrams, so they one from online, right? Kind of skew and this. Skew and that. SKW, yes, skewness, right? That's now I'll show you it here. Let me see if I can pull it up here. I want it very bad, but I like to get you that. Huh?
That's it. This is a measure of international relationship.
All right, what you see online? Look at that around there. Suppose I have that in the something like that. I mean, in my. Hold on, yeah. Right. So we know about quartiles, right? We know about quartiles. Hold on there online. Where did I go? All right. So I want to show you the shape first, right? Okay, watch this here. It's the one that we have to really focus on, right? Right? We're focusing on this here. Right? So diagrams could be skewed. The diagrams, all the data could be perfect. Perfect meaning. Right? Perfect meaning that this here is the mean, that there is the mean, and all your values on either side are equally distant away from it. Okay? So that's symmetrical diagrams, right? that symmetrical diagram has no skewness. So the skewness here is 0. Right? The skewness here is 0. And how will you know that? Look at the diagram here. If you box and whisker perfect, meaning that the whisker here to here is the same as the whisker from here to here, and the distance between here equal, it means that you have something that's symmetric. It means that your median is perfectly in the middle of your smallest and largest value. Okay? So that is called symmetrical. Then you have something called left skewed, something called right skewed. We don't really use those words, right? We use positively skewed. It means that most of your values on the positive side, and you have negatively skewed. All right. How you know them? Look at the whisker here. You recognize for left skewed, right? The whisker here larger, and the Q1 and the Q2 parts, right? So here's how you remember it. In left skewed, the Q1 and the Q2 do like each other. In the right skewed, the Q2 and the Q3 do like each other. Or the reverse. Q2 and Q3 dealing in left skewed, and Q1 and Q2 dealing in right skewed. Right? So you can remember whichever one. Right? So to my favor and draw those diagrams. Right? But under the diagram, draw the box and whisker just like that. So when you see it, you know how it looks. All right? Right? Draw all 3 diagrams with the box and whisker on it. Do not take a picture of it. Draw it. Right? Don't mentally watch it either. Draw it. That's you. People like that. Sorry. So you will have the memory and the close memory, but it we might do have that.
Surprise, and they were the see which right.
That's not. Just remember for your skewness, shift the big part, the top to the right in one, and to the left in the next one, right? I haven't just one done. I forget the mother. Yeah, that's it. First time you but I will put it. Right. So. Finish. Okay, so if box and whisker could come, the box, why the box numbers are important. Then the next way you can do it, right? You can outline in the data on this stem and leaf, and you can see the shape. Right, so the details and thing and looking at the whisker to give you an idea what type of skewness it is. So you have to look at the whiskers and you have to look at the where the quartiles are, right? That the left side is even negative, right? That's negative. 100, you don't have or the value say all the long theory. Profile the values. All right, let's just look at something here. Hold on, huh? Okay. This in right? So again, I remember I told you sometimes they call them positive and negatively skewed, right? Positively skewed, right? Just to mark paper and go back to your diagram, right? Go back to your diagram and relabel them now. Positive skewed would have been the right. Right. The positively skewed would have been the right skewed, and the negatively skewed would have been the left skewed. Yeah, right. That's right. Okay, so let's go back over and label here. What it means? Watch this here. Let me show you. When I said, let me show you before you mix it up, right? Hold on. Watch this here on the code. Empty board here. Right? So watch this here. So these are your values, right? You have 0, you have positive and negative values. If it's perfectly skewed, it means that your values on both sides, right? Your values on both sides are the same. So you have equal amount of values here and here. So it will look something like that. Right? That's symmetrical. Right. If it's positively skewed, what that means is that if here is 0 and here positive, it means that your values, you don't really have much values there. But your bulk of your values on this side. Right? That's positively skewed. Negatively skewed is the other way around. Right? You hardly have values here, but your bulk of your values on the next side. That's okay? So in that, what they had called this one here, what they had called positively skewed, right skewed, right? And negatively skewed, they call it left skewed. All right. But we don't really use left and right. We more use negatively skewed when the lower part here, right? It's on the negative side, and we use that positively skewed. Okay. How you get it? You have to do the clocks and whisker and look at how it's shaped. Or there's one more thing you could do, and you could use your stem and leaf. So if, for example, your stem and leaf looks like this. Right? If your stem and leaf looks like this, take your stem and leaf and just shape it out. How that looking? Symmetrical, and right? But if on the other hand, your stem and leaf was like this. So your majority of your values here and a few values here. What's that? Are looking positively skewed, right? They're looking like this. That's okay? The majority on the left side, right? That's okay? That's why I show you left skewed on thing as well, right? But if you say left skewed or right skewed, you'll still get it right. Okay? You okay with that? So that is it for the first part of stats. Next week we start the real thing, probability. Right? Probability can be real easy or real hard. Okay? But this question here, make sure you can get full marks in this. Test on this next week.
Yes.
Yeah. Don't test.
Okay.